All right, class, today we're going to graph rational functions. We're going to do this for 2 days. Again, the steps you want to go through: factor the numerator and denominator, and reduce. If something does reduce out a factor, that means you have a whole. If not, then you have to then move on and find the x and y intercepts and their multiplicity. Then we want to find the horizontal and vertical asymptotes and state their multiplicity. Well, usually you only have multiplicity for x, the x stuff, so the vertical asymptotes and the x-intercepts. And then graph. So let's see this first one here. Hopefully you guys realize that the top factors, two numbers that multiply to 12 are 4 and 3, where 4 has to be the positive one. Okay. The bottom is difference of squares, so we got x plus 2, x minus 2. So I look at it, nothing cancels, which means there are no wholes. Next, we have to find the x-intercept, which means that that's when y is equal to 0. So if we look at this, in order for the fraction to be equal to 0, the top needs to be equal to 0. Because you don't do anything with the bottoms, because the bottoms are, you can't have a 0 on the bottom. So if you set the top equal to 0, so top, you get that x-intercepts. You get the points 3, 0 and negative 4, 0. Since they are both to a power of 1, they both have a multiplicity of 1. Then we do the y-intercept. The y-intercept is just plugging in x equals 0. So f of 0, or the y-intercept, is equal to 0 plus 4 times 0 minus 3 over 0 plus 2 and 0 minus 2. And we get 4 times 3 is negative 12 over 2 times negative 2, negative 4, which is positive 3. So the y-intercept is 0, 3. Again, we don't do multiplicities for the y stuff. The vertical asymptote is when the denominator is equal to 0. So we have the x plus 2, x minus 2 equals 0. This is also like your domain. So we get x equals negative 2 and x equals 2. These are both odd because they are both a multiplicity of 1. I'm just going to say odd, and I'm going to say odd up here too as well. And finally we look at the coefficients, or we look at actually the powers, I should say. And if you look at before you even simplified this, we have x squared over x squared. So since it's x squared over x squared, we look at the numbers in front. But since the numbers in front are both 1, we get that the horizontal asymptote is at y equals 1. Alright, so now we're going to start sketching this stuff in here. Vertical asymptotes at negative 2 and 2. And we know they're both odd. That'll matter with how we talked yesterday what it looks like at an odd asymptote. It is also odd. We also know the graph crosses at both 3, 0 and negative 4, 0. We also know that there is a horizontal asymptote at 1. So, based on this information, you can assume that since it's crossing here but it's going to end up there, it's going to look something like this here on this side. And since it's crossing, it's going to go down to this vertical asymptote. Since it's odd, that means that on the other side of this line, it has to start up here. Now, the only issue you have here is, does this go all the way down and through, or does it go back up? Since there is no x-intercept in between these two vertical asymptotes, we didn't get any in here, that means that, and we know the y-intercept is, I forgot to plot the y-intercept, 0, 3. That means it crosses and it probably goes back up. Okay? And it does. So anyway, we have that. And then, since it's odd again, and we went back up here, we have to come from the bottom. And if we come from the bottom, we have to go through our 0, which we do, and then we go off to the side. So that would be our graph of this equation with all the information that we were provided. You can check your graphing calculator, but remember this this quiz is non-calculator, so you should be able to do all this without a calculator. Then the last step would be but if you ever want to check, you can. All right, let's do one more today. Again, we first factor. That's the first step. The top becomes 3 times x minus 3. The bottom becomes x plus 3 squared. There are no holes again, because again, nothing cancels, so we say none. The x-intercepts when y equals 0, which means the top is equal to 0 when you're dealing with a fraction only. If there was a constant, that's a whole other issue. You'd have to set the whole equation equal to 0. But so the top's equal to 0, so we say x minus 3 equals 0. So the x-intercept is at 3, 0. And it is odd, which means it crosses. Sorry. So, crosses there. The y-intercept is when we put 0 in for x. So I'm going to put f of 0 in. And I get 3 times 0, it's minus 3, right? Over 0 plus 3 squared. So we get a negative 9 on top when you multiply it with negative 3 times 3, and we get a 9 on bottom. We get 1. So we get 0. I should say that's a negative 1. There we go. So now I have the y-intercept. Now for vertical asymptotes, we want to see when the denominator is equal to 0. So again, x plus 3 equals 0. We get the vertical asymptote of x equals negative 3. However, this is even because it's squared up there. So that means that we'll see what that means when we get there, but we did talk about that. And then finally, horizontal oblique. Since the powers, the highest power on top is 3x, the highest power on bottom is x squared. When it's bottom heavy like this, it's just whatever the constant is next to it, but there is no constant, so it's going to be 0. So y equals 0. Okay, so we have our horizontal asymptote at 0. We have our vertical asymptote at negative 3, and it's even. And we have this point and this point right here. So this is a weird one because it's showing us that we want to start on the right because there's more information over here. It's showing us that it's going down, it's going through this. Now here's what's weird. This is one of those weird scenarios where it'll cross, but then it'll like approach. So it'll be on this side of the asymptote but then go off forever. Sometimes it does that. So we have that. Then, because this is even, you do not start at the top here. You start back at the bottom, and then you just kind of have it go off towards the horizontal asymptote. Because even means that they both go the same direction. Okay, so that is graphing rational functions. Day 1.